So hi guys. So I said that before I start the next class, I will be going over the practical application of actually the practical way of actually reading your vernier caliper and your micrometer scale. So before we start scalars and vectors, I would like to start with this. Now in this diagram, now you have two different readings. Now in the first, you have where you have something that is greater than 3, that is greater than the actual, that is greater than the smallest division on the main scale. While for the second one, the reading that you are picking up is less than the smallest division on the main scale. That does not mean that the instrument is faulty or something. So, but then let's start with the first one. Now, so to read your vernier scale, use your vernier caliper, you start with the main scale. Now you're going to stop your reading of your main scale where the line on the vernier scale starts. You're going to stop your reading of your main scale where the line on the vernier scale starts. So you have something like this. So you have this. So where that circle is, that's where you're going to stop your reading of your main scale. This line, that particular line. And that should be 1, 2, 3. That should be 3.3, 3.3, 3.3 centimeter. So that will be what your main scale now will be 3.3 centimeter. 3.3 centimeter. Now you now jump to your vernier scale. Now you are going to stop your reading of the vernier scale where the lines on the vernier scale coincide with the line on the main scale. So let's go through this. You have so where the line coincides with the lines on the main scale is this 4. Is this 4 you have here? This one, the one before 5. So that's where you have your read. So now your vernier scale, your main scale is what? 3.3 centimeter. While your vernier scale now, your vernier reading is 0.4. Now why is it 0.4? Because I told you that each divisions, that means from 0 to this one, to this small line there, is 0.1 millimeter. So that means you are going to, and since you have 4 divisions that you are counting there, so that will be 0.1 millimeter times 4. So that will give you 0.4 millimeter. Now don't forget that you have your reading on your main scale, which is 3.3 centimeter. So now you notice that the units are contradicting one another. So you have to check your option and look for the reading and look for the units that is being used in your option. If it is meter, if it is in centimeter, then you have to convert this millimeter to centimeter. But if it is in millimeter, then you have to convert your centimeter to millimeter. Just make sure that maybe you convert to centimeter and then your options will be in millimeter. You still have to convert again back. You still have to convert back to millimeter again. So you have to check your options before you actually do the conversion. But I'm going to assume that okay, the stuff is in millimeter. So I'll convert this 3.3 centimeter to millimeter. So that would be what? 3.3 times 10 is to the power minus 1 times 10 is to the power 1. So that would be 33 millimeter. So now when you now add 33 millimeter plus 0.4 millimeter, you're going to have what? 33.4 millimeter. So that will be your reading on this for the first reading. Now let's now go to the second. Now this is a little bit somehow because now there is no reading at all on the main scale because before the stuff even hits 0, your vernier caliper already starts reading something. So what you're going to do, you're going to ignore your main scale. So your main scale will be 0. Your main scale will be 0 centimeter. Now you're not going to go to your vernier scale. Check where the lines coincide with that of the main scale. So that should be this. That should be that line. So that's 6. Now don't forget that each divisions now is what? 0.1 millimeter. So that would be what? 0.1 millimeter times 6. So that would be 0.6 millimeter. So when you now add your 0 from your main scale, because if you convert 0 from 0 centimeter to 0 to millimeter, it will still be 0. So if you add that plus your reading on your main scale, on your vernier scale, which is 0.6. So you have a 0.6 millimeter to be your reading for this vernier scale. I hope you understand that. Now let's go to that of the micrometer screw gauge. Now your micrometer screw gauge is very similar to your main scale, just like it's just the arrangement that is a little bit different. Now moving on here, you have your main scale. This is your main scale, and then you have your vernier scale or your thimble scale, which is this. So what you're going to do now is the same thing you did for vernier caliper. Start with your with your main scale. What can you pick up on your main scale? You have what? You have one, and don't forget that your micrometer scale is graduated in what? In millimeters. So you have you have 5.5 because you have 5.5 because here notice that your you notice that you have your 5 and then you have a small line down below. That small line below is like dividing each of the uppermost division into 2. So that means if you have from 0 to 1, that means that small line will be what? 0.5. So that means you have what? 5.5 millimeter as the reading on your millimeter, as the reading on your main scale. So you have 5.5, but then they basically just converted it to centimeters. Now after reading your main scale, now then you jump to your thimble scale or your vernier scale. Now let me zoom in. Now for this, you're going to ensure that where you're going to stop your reading on your main scale, on your vernier scale or your thimble scale, is where the line, this horizontal line of the main scale coincide with the lines on the thimble scale. And where is that? That's at 10, 11, 12. So that's at 12. So now you have 12 divisions. Now don't forget that I told you that each division on a thimble scale of a micrometer screw gauge is what? 0.01 millimeter. So that's like 12 times what? 0.01 millimeter. So that will give you what? 0.12 millimeter. Now basically what they did there, just they converted the millimeter to what? To centimeter. When you convert the millimeter to centimeter, you're going to get 0.012. So after that, you just add what? You add the two, your main scale and your thimble scale together, and then you get what? Your total reading, which is what? 5.5. Okay, let's do something. 5.5 millimeter plus 0.12 millimeter. So that will be what? 5.62 millimeter. Then get that to convert that to centimeter to still get the same reading that they got. I hope you understand it now. So now moving on, let's now go to today's topic, which is scalars and vectors. And these questions are usually, like most examiners, like for me now, if I was to set any question or any test for you, I always tend to like dive more into this because I can be this topic can allow you to be very flexible. You have a lot of things to actually hacks on this particular topic. Okay, so what do you understand by scalars? Now scalars are quantities. We already talked about physical quantities before. Now this is just like categorizing them based on whether they have direction or just magnitude alone. So scalars are quantities that have only magnitude, they don't have direction, while vectors are quantities that have both magnitude and direction. And what that means is magnitude in terms of okay, when you want to quantify them, you can quantify them, but then does that quantity have a particular direction that you are quantifying it? I don't know. I think that English is might be a little bit confusing. What I mean is, let's say you are measuring the length of a table. Now you measure the length of the table to be 20 centimeter. Now was that 20 centimeter in a certain direction? No, because if you have to measure the length of that table, it's like you're measuring in both directions. You have a starting point. Phew. Maybe the length is okay, is in this direction per se. It's just you can try to measure it from either side of the table, depending on which you actually prefer. So that's what scalars mean. They don't only have magnitude, they don't have direction. Why for vectors? They have both magnitude and direction. For example, if a man is going somewhere. Now, he's covering distance. The distance that he is moving, if you are to consider the distance alone, it has no direction. That's a scalar quantity. But now, if you are not talking about his displacement, you are talking about, oh, where did he go to? So you get. Now, he went 36 kilometer north of east. Now, in that case, now you've turned that distance, which was initially a scalar, to what? To a vector, because you've added direction. You get. So that's basically what scalars and vectors means. Just vectors have direction and magnitude. Scalars only have magnitude. They don't have direction at all. And there are certain examples, and there are some examples of scalars and vectors that will definitely confuse you if you don't know them before you enter your exam. For example, pressure. Pressure is, because normally if you are feeling pressure, you think maybe pressure is a vector now, because I'm applying pressure. But then that's not the case. Pressure is a scalar quantity. Why is that so? Because if you notice, when you apply force on a certain area, you are getting like something that is antagonizing you. Like there's something that is going the opposite direction to your own force, and that force will cancel out, except if the force that you are applying is greater than that force, and then the surface will break, and in that case, it's not more like a pressure anymore. It's like actual force. So unless you have that kind of case, every pressure you apply on the surface, so far the surface does not break, is a scalar quantity, because the forces are cancelling out, and when they are cancelling out, that means what they are zero. They have zero direction. They have zero magnitude. So that's why it is it's a scalar. And the other, let me just list some examples of scalar quantities that you might need to know. Surface tension also is a question they can ask you. Is a scalar quantity. It does not have direction. Even though the formula of calculating it is what? Force over length. It does not have direction. And it does not really have direction. It's because it's just like it's similar to that of pressure, where you have a force or an opposing force that is cancelling it out. The same thing for surface tension too, because there is a force already that is going in all directions, and the fact that they are going in all directions, they will cancel out. So the net force now will be zero. And what is actually causing the stuff to actually be a vector, to have direction, versus what is the force? And if the force is gone, that means what? There is no direction. And if there is no direction, that means stuff is what? Is not a vector quantity anymore. So so you have surface tension as a scalar quantity. You have your distance, you have your time, you have your temperature, you have your you have your thermal conductivity, you have your gravitational constant, you have your all constants. Let me just take this. All constants are scalar quantities. All your potentials, like electric potential, gravitational potential, this potential, they are all scalar quantities as well, because potentials are like work done in moving so, and work done in that case is what is a scalar quantity. Yeah, work done is a scalar quantity. Speed is a scalar quantity. Distance is a scalar quantity, as I said before. You have a lot of other scalar quantities. So I would advise you that you actually consult your textbook, study these materials yourself in your textbook, and then write those quantities out, so that in case you are asked, you won't have any issue. And then for your vectors, we have force, we have velocity, we have displacement, we have acceleration, we have now all field strengths are vector quantities. Example: electric field strength, gravitational field strength. All of them are scalar quantity. All of them are vector quantities. What else? Yeah. So you can consult your textbook for the remaining physical quantity, for the remaining vector quantities and scalar quantities. Now there won't really be much talk on scalar quantities addition, because for scalar quantities, since they only have magnitude, so if you are to add them together, you just add them directly together, because they are not considering another thing. It might be, oh, it is increasing in this direction, so you have to consider, okay, this particular quantity, this particular value that was given, it was increasing in this direction, and this other value that was given was increasing in this other direction. So I have to consider the fact that, okay, if they are both acting together, they will more of like want to like antagonize one another. That's not the case, because they don't have direction. So you just have to just consider their magnitude alone. So for scalars, when you are asked to add scalar, like, oh, what is the total distance covered by the man? It will just be what? Addition of all the distance that the man actually covered throughout the entire journey. That's all. No need to do any calculation whatsoever. But then for vectors, that's where the problem comes in. For vectors, you have to consider the direction, because there's the thing. Let's say you are trying to, like, let me use this as a perfect example. I think everybody can relate to this. You attach a rope to a load. You and two persons are trying to like move the load. So you attach two ropes and then you are pulling it forward. The other person is pulling it forward. You notice that both of you, the load will be like, imagine if it was only you that was initially pushing it. The load will not, the progression of the load, like the movement of the load, will be very slow. Now imagine another person joining you, and then both of you are actually pulling it in the same direction. It will be faster. Now imagine if the other person now decide to be going in the opposite direction to your own movement. Like, instead of the person like working with you, the person is working against you. You know that you might not even move the load at all, because the person's force is antagonizing you. And as a matter of fact, the person might even be like moving it more than you, so that the person will even be pulling you back. That's because the person's magnitude, the magnitude of the person's force was greater than yourself, and the direction of their application of that force is also opposite to yourself. So that's where addition of vectors becomes complicated, because you have to consider the direction as well, because the direction has a very huge impact on the magnitude that you're going to get. Have I talked about the difference between scalars and vectors? I think I already said that one has direction, one does not have direction, one has and one has only magnitude, the other one has both magnitude and direction. Okay, now for dot and cross products, I will not talk about it because it won't be asked in your UTME. Now it is when you come for post-UTME that, especially for those that will be applying to UI, that will talk more in depth on dot and cross product of vectors. But then if you're able to cover the entire topic before your UTME, you can just tell me, send me a message, and I'll try and send a video explaining this. But then for now, you don't really need it. So let's just cover the important stuff that you'll be asked. Now let's not talk about resolution of vectors. Now there's something called coordinates. We have x and y. Now we have z. But then we won't really be talking about that, because most of the stuff we'll be doing will be on a plain sheet. So, and on a plain sheet of paper, you only have two dimensions, which is the length and the breadth. That's where you have your x and y. But normally, if you talk about normal spatial placement of an object, you have three dimensions. Now, for your x is on the horizontal plane. Your x is on the horizontal plane. Something like this. Your x on the horizontal. While your y is the vertical plane. Okay. Now, there are some vectors. Now, a vector can act on just x direction, on just that x-axis. If it's acting on that x-axis, then it is fine. And also on that x-axis, you have two sides. Now, you notice that the way they always say that, okay, if you use your right hand to give someone something, then that means you're a good person. Or that means that, okay, hey, or mother than, like, you're a very good person. While if you use left hand, they will correct you, they will scold you that, oh, that's wrong. That's the same thing you have for this x and y plane. Since it's on the horizontal plane, so you have left and right. Now, for the left, it is what is the negative. For the right, it is what's positive. So you should use that. And also for your y-axis as well. For your y-axis now, you have what? Up and down. Now, when you are going up, is that a good thing? Yes, it's a good thing. When you are going down, is that a good thing? No, it is a negative thing. So anything below the y below the zero origin on the y axis is negative, while anything above the o origin on the y axis is positive. So just take note of that. So if a particular vector is acting on just the y plane, then it is positive. While if it is acting on is acting upwards, it is positive. If it's acting downwards, it is negative. Like I'm pulling something downwards. That's my own effect. What I'm doing is wrong. So it's negative. Someone's trying to go up, I'm trying to pull the person down. That's wrong. So it's negative. While if someone is trying to climb up and I'm trying to like push them up, oh yeah, like the way I'm doing for you guys now, then push you up, then that is a positive thing. Do you get? So now there are actually some vectors that they don't really that they don't really go in either x and y. They are more like something like this. They are more like something like this. So they don't really belong to x. They don't really belong to y. They possess both. So for those kind of vectors, then you have to learn how to resolve them. Resolving them into their respective x and y components, since they don't really belong to any of them. So and they incorporate the two axes together. Now, for the resolution of these forces, you need something from math. Let's borrow from math. You need what? So, car, toi. Now, what does so means? You should remember this from math. So is for what? Sine theta equals to what? Opposite over hypotenuse. Chi is what? Cos theta equals adjacent over hypotenuse. Tan is what? Tan theta equals opposite over adjacent. Now, for resolution of vectors, you don't really need tan. You don't really need this toi. What you need is what? Just this so and then the car. And this is the way you know. And you know, I was saying something about you having sine theta equals opposite over hypotenuse. Yes. The same way too, you can have you have cos theta equals adjacent over hypotenuse. Now you will be in order for you to know your opposite, your hypotenuse, your adjacent, you need to know what theta is. And for you to actually determine to know your theta, let's do this. We have something like this. Theta. And don't forget that you use so car and so for triangles. So if you have this kind of setting, what I will let you to do is what? Complete the triangle. Just add this line. So now you have what? A triangle. Now theta, now you have your theta now, yeah. Now the angle facing oh, so I said the angle. The line, the side of the triangle facing the theta will be what? Your opposite. The line adjacent to your theta is your adjacent, like adjacent to it, adjacent. Why the longest line usually, but I also don't like to say the longest line. Usually the longest line, the other line, the extra line that is left is now your hypotenuse. So now you are able to identify your opposite, your adjacent, and your hypotenuse. So you'll be able to do what? Resolve your vectors now. But then before that, let me give a perfect scenario. I don't know why this thing is this long? Is this big? Okay, moving forward. So let me use this. Let's say this is 30 degree. This 30 degree. And then the force, is it the force? You actually the force. Yeah, the vector, let me use the vector. The vector I'm trying to resolve has a magnitude of what? 20 degree. Of 20. And it's moving in this direction, yeah. So you notice that this is not really going in the x or the y direction. So it is what is inclined. So we have to resolve it. Now I told you that okay, your angle is your theta. So they've given you the angle already. So you know your theta. Now let's identify our what? Opposite and hypotenuse. Now opposite is what? I said before that opposite is what? The side facing what? The angle. Why the side adjacent to your angle is what? Your adjacent. Why what you are given now is not what your hypotenuse. So now you observe that your opposite is what? In the y-axis, it is vertical. So that is what? Your vy. Why your adjacent is what? On the x plane, it is what? Your vx. Okay. Now with that said, now let's now resolve. Now let's start with x. X is what? Our x is what? Our adjacent. So that, and we have what? Our hypotenuse. So that's what? AH. That's car. So I'm going to use what? Car. That will what? Cos 30 degree equals 30 degree equals adjacent is Vx all over hypotenuse, which is what? 20. So making Vx the formula, you're going to have what? 20 times cos 30 degree. Now another additional bonus that will help you in your exam is for you to know some of these special angles, like cos 30 degree, sin 30 degree, cos 60 degree, sin 60 degree, cos 45, sin 45. All these things, they will really help. They will go a long way to actually help you. Now cos 30 degree is what? 0.866. Now some people know this thing in short form. I think it should be root 3 over 2 or something. I can't quite remember. So now cos 30 degree is 0.866. Now 0.866 times 20 will give you that should be 16, like 16.2, basically 16.2. So that means your x component is 16.2. While your y component, now you are going to use your sine for it. So just replace this cos with sine, and then you replace this vx with what? With vy. Now making vy to the formula, you are going to have what? 20 times sine 30. So you are going to have what? 0.5. Your sine 30 is 0.5. Punch it into your calculator, you are going to have 0.5 times 20. That will give you what? 10 Newton. So that means your vy is what? 10, while your vx is what? 16.2. What we get. So that's the way you resolve your vector. Now, how to determine the resultant of two or more vectors using geometric and analytical method. Now, analytical method require you breaking them down into the x and y components. So now you have multiple. Now in that case, the one I just did now is just one vector alone. Now there's cases where you have multiple vectors acting on a single point, like something like this. Something like this. I think this should remind you of something, Lami's theorem, but then we're not going there. So it's possible for you to have something like this. Now when you have something like this, then, and all of them are, most of them actually, two of them are actually inclined at an angle. So you have to resolve them. And after resolving them, then you have to find a way to add them together. And don't forget that I told you that when you're adding vectors together, you have to consider the direction. That's where the resolving of those vectors come in. And also, don't forget that when you are resolving, the one I did now is the simple part, like the way they usually do secondary school, where the example will be the simple ones, and then the one that you do in your exercise will be the difficult one. Now, don't forget that I told you that we have two sides on your x and y plane. So if the direction that you are following now, that the whole stuff is in, is towards that side, that means your vector has to have a negative sign. Like if it's going towards x, towards the left on the x plane, then that means it will be like minus, like for the one we did before now, it will be like minus 16.2. I mean the direction of the stuff was this. I mean the direction of the stuff was this. Instead of the normal this that we did. So this is going towards the left. Just always use the left, right, up, downward signal. So if you notice that the top is going towards the left, it will have negative sign. If it's going towards the right, it will have positive sign. If it's going upwards, it's positive. If it's going downwards, it's negative. Just use that. So now for your analytical method, you have to just resolve them. So you're going to use your normal resolution to resolve those vectors down. I think this thing is taking like long. Jesus. Okay. So I'm going to use your normal resolution to resolve those vectors into the x and y components. Now you should add the sign to it if it is going towards the left or the right. Now after adding the sign, that's for analytical method. You have started adding the sign, then you add all of them together. When you add all of them together, you have, let's say you have fx, fy. Let's say some of the values you have here is like -1, 2, then +4. Then here you have -3, -6, and 10. Now yeah, you are going to add all the values that you have in your x column together. Is that column? Yeah, no rule. So you are going to have -1 + 2 + 4. So you're going to have that should be 5. Now for this one, you have what? -3 plus open bracket -6 close bracket plus 10. So that should give you 1. Is that -1 or +1? It will give you +1. So that's how you do the addition. Then after doing the addition, then you are going to draw a triangle like that one. Now we had +5 on the x plane. So you have what? You always, since it's +5, so that means it has to be going towards what? Towards the right hand side of what? Of your x axis. And then you have -1. Minus what will be going downwards. So then you what? Complete the triangle. Oh no, you shouldn't complete the triangle that way. You have to complete the triangle this way. I'm coming. You have this. You have this. Now your resultant will always be a combination of the two vectors. So now, since this one is going downwards, this one is going towards the right hand side. So that means what? Your resultant will be what? Going towards the right hand side, and also what? And also downwards. That's why I cancelled that the other time. Although either way it would have mattered, but then it will affect your direction if you had used the first one that I did. So it's for you to like use this. So when you're trying to calculate your direction, you will be conscious of the fact that okay, this thing is going towards the right and then downwards. So you know what your direction will most likely look like when you're using north, south, or distance. So now then after having this, then you're going to just complete the triangle. These two sides of facing one another will have the same magnitude, the same thing here. So you just bring out a triangle from it, and then you use your Pythagoras theorem. Since it's a right angle triangle, you use your Pythagoras theorem, which is r squared equals a squared plus b squared, where a and b are one of the sides of the triangle, and then your r squared is like the hypotenuse, the one going the resultant. So that's that for using analytical. Now for your geometric, that's why you use your parallelogram method, your cosine rule. Now I always tend to give students this formula instead of the normal. Okay, when the angle is so, it will be this. Because if I give you that, I've used that formula in some cases where I got the answer wrong. But then if you use this and you understand this very well, if you understand this formula very well, if you understand this particular formula very well, you won't have any problem. This formula, you won't have any problem. Just know that your theta is the angle between the two vectors. So let me give you all those different cases. Like you have something like this. You have something like this. You can have something like this. And then you can have something like this. Just have to take note of direction. Now, I know that the theta in that case for this formula is the angle between the two vectors. And now we know whether something is between the two vectors. Is if both of them are facing almost the same direction, like this now. This is the angle between these two vectors. This is the angle between the two vectors. But then this is not the angle between the two vectors. What to know the angle between the two vectors, then you complete the whole setup. I'm coming. So you have something like this, you have this. You have this, and you have this. So to know to determine the angle between two vectors for this kind of cases, those other ones are simple. Extend the sides of the triangle, add their direction. Sorry. So you have this. Now look for where both of them are like leaving the point. Where is that? You have this place. So this will be your angle between between the two vectors. So once you're able to identify the angle between the two vectors, you won't have any problem. And then you are Gucci for your geometric method, and you will always get the answer right. So far, you're able to identify and locate the angle between the two vectors, which is the theta. So the parallelogram law is what? R square equals a square plus b square minus 2ab cos 180 minus theta. Now we are going to talk about relative velocity and relative velocity under motion. So that will be all for today's class. So if you have any questions, you can drop it on the class group before you actually take the exercise. So I will use a VN to explain thoroughly. So see you guys in my next class.